Hi, welcome to Algebra 2 Common Core. Tonight in lesson number 8, we're going to take a look at a measurement that's called the difference of the means. And then we'll talk about what something means to be statistically significant. So let's look at exercise number 1. We have 20 adult drivers, and they were asked the question, what speed is the fastest you have driven? The table below summarizes the fastest speeds driven in miles per hour. This sounds a little bit dangerous because these numbers look a little bit big, but we're just using it as an example. So the first part of the question says, let's calculate the mean of these speeds to the nearest hundredths. So I want you to pause the video and take out your calculator and find the mean. Then also go on to part B and calculate the range of the speeds by subtracting the maximum speed minus the minimum speed. When you've completed that task, then start up your video again and compare your answers with mine. So I got for the mean of these 20 speeds to be 69.25 miles per hour, and I got the range to be 110 minus 40, which is 70. Now, what we'd like to do is take a look at these 20 speeds and talk about what happens when we divide the people up randomly into two equal-sized groups. So again, the important word here is that we're making this division randomly. I'm not taking the first 10 scores and then the second 10 scores. I'm going to do a random separation here. So let's talk about how we can randomly select my groups of 10 people. We could use our random number generator. Remember that we have a random number table. We could also put the 20 numbers from 1 to 20 into a bag and pull out 10 of them. So in some way we want to find a random group of 10 of these. I'm going to go back to our random number generator on our calculator to make sure that everybody is really familiar with that. And I'm going to select 10 of those speeds to put into the first group, and the other 10 will be in the second group. So let's talk about how we do that again on our calculator. So once again, I'm going to use my random number generator on the calculator. I'm going to randomly pick 10 of the people, and those 10 will go in the first group, and then the remaining ones will go in the second group. So let's recall how we do this on our calculator. I'm going to hit the math key, and then I'm going to arrow over until I see probability, and I'm going to choose number 8, which is my random integer with no repeats, telling my calculator that my lower number, my lower interval is 1 up to 20, and I want to pick 10 of them. Now again, remember that if your calculator gives you an error when you do this, then just generate one number at a time, and if you repeat numbers, then don't count the ones that you repeat. So I'm going to use my calculator and I'm going to pick 10 of these speeds. So on my calculator, I'm generating my random number generator, and I'm getting, the first number is the 10th person. Then I've got the 14th person, then the 13th person, then the 6th person, person number 3, person number 1, person number 5, person number 9, person number 18, and last but not least, person number 4. So I've got 10 of these speeds that I'm going to call group 1A. So go ahead and put those numbers in group 1A and put the remaining ones in group 2A. Once you get those numbers in, please calculate the mean for each group. So I listed down all of the ones that I chose using my random number generator, and I took the mean of those scores and I got 69. The ones that were not circled from the above list, I put those in group 2A, and I calculated the mean of those, and I got 69.5. So question C says, do you expect the means of these two groups to be equal, why or why not? Well, I'm not going to expect these means to be equal to each other. Of course, it's always possible, but I'm going to say no, it's not expected because I can have any random group of 10 of these speeds. But, of course, it is possible for the two groups to have the same mean. So I did the calculations, and I got 69 and 69.5. So the question is, how do these two means compare to each other? And then what about to the mean of the whole group? So comparing those two numbers, I see that the first group had a mean of 69, the second group a mean of 69.5. Yes, these means are very close to each other. And given the fact that the mean of the whole group was 69.25, both of these means are also close to the whole group mean. Now, the calculation that we're going to be looking at a lot in this lesson is going to be called the difference of the two means. It has a special name. It's called the diff value. So to do that difference, we're just going to take 69.5 and we're going to subtract 69, and we see that our diff value this time is 0.5. So again, I'm going to call that the diff. Now, I'm going to repeat this choosing of 10 random numbers 2 more times. So I'm going to make group 1B and 2B, and then I'm going to make group 1C and 2C. So again, using my graphing calculator, I am going to go ahead and do random numbers from 1 through 20, and I'm going to select 10 of them. I'm going to list down those 10. So let's see here. Let's go ahead and do this on my calculator. And when I do that, I'm looking again at person number and getting the speeds for those people. So my next group is going to be 55, 60, 95, 70, 75, 50, 65, 55, 70, and 75. Now when I did that, that left me with these numbers: 65, 110, 70, 65, 70, 65, 40, 90, 80, and 60. So again, pause the video and find the mean for each of those lists, each of those groups. One mean for group 1B, the other mean for group 2B. So I got the means 67 and 71.5. Now, I'd like you to randomly select the next 10 and put them into group 1C. Whichever ones you don't use for group 1C, you're going to use for group 2C. So please find 10 numbers randomly selecting, and then put the rest in the second group and find the mean for both groups. So everybody's answers here are going to be different because I'm going to be selecting randomly for these groups. So here you can see my next set, and I calculated the two means to be 69.5 and 69. Now we're going to take this data and we're going to say, what happens if we do this 100 times? And then create a dot plot with all of those means. So again, I'm taking a look at the 10 and then the 10 that are left out and go ahead and do the means of those. Let's examine what the dot plot would look like if we did this 100 times. Now recall that when we did the mean of all 20 of them, we ended up with a mean of 69.25. So I'm going to go ahead and put that right on my chart right here. 69.25 was the mean for all of the data together. Now, when I calculated all of these means of the two separate groups and I plotted them, I see that I ended up with a dot plot that has a shape that is called mound-shaped. It's mound-shaped just because it's got a hill in the center. It's also symmetric around the mean. And I see that it's got a pretty significant spread. I think I didn't spell significant right there. I got too many I's in that answer. So there's not an I after the C. So what results can we take from this? When I do the groups, the group means tend to differ just by chance. We randomly put the numbers into two separate groups, and we randomly came up with means. So the group means are going to differ by chance. The distribution of the random group means will be centered at the single group's mean. So we can see that 69.25 is really right in the center. The distribution of randomness, group means, should also be symmetrical. Now let's specifically target. I'm going back to those 20 speeds, and I want to say, okay, what happens if I pick off the 10 smallest values and put them into one group, and then take the 10 largest values and put them into the other group? Let's see what the average of those two groups would be. So let's take a minute and separate into smallest. So I see definitely 40 is the smallest score. I see then that I also have a score of 50. I have a couple scores of 55 here, so they're going to fit into the small category. And I see that I've got a couple 60s. And let's see, 1, 2, 3, 4, 5, 6. I've got 6 so far. So I need 4 more, and this is nice and convenient. There are 4 65s. So those are all the smallest scores. So I want you to stop your video for a minute and use your calculator to find the mean of those circled numbers, and then also find the mean of the numbers that were not circled, because then we'd have the mean of the largest and the smallest, and fill them in below. So calculating the means for each of the groups, I got that the largest mean was 80.5 and the smallest mean was 58. When I calculate the diff value by subtracting, I'm getting a diff of 22.5. Now, are these difference values likely to happen by chance? Well, it could happen by chance, but it's pretty unlikely. It's unlikely that I'm going to get a group where all of the first group is going to be the smallest and all of the second group is going to be the largest. In exercise number 2, we're going to take a look at what this difference value means. So, suppose that the data originally came from two groups. One that had been taken from a group of students who took driver ed before getting their license, and one that was taken from a group that did not take driver ed. So the data values of the two groups are shown in the table below. So first of all, I'd like you to find the mean for the driver ed students, and then find the mean for the no driver ed students, and calculate the diff value. So I got that the driver ed students had a mean of 61, and the no driver ed students had a mean of 77.5. So when I calculated the diff value, now there's some question, how do I know which way to do this subtraction? I'm going to do it as the treatment versus the non-treatment. So 61 minus 77.5 is giving me negative 16.5. What does that difference value mean? Well, it just means that the students who took driver ed had a smaller mean than those who did not. So you'll notice that because I did the subtraction in that order, I ended up with a negative diff value, showing that the students who took driver ed had a smaller mean than those who did not. What would a positive diff value mean? That would just mean that the two groups switch places. So a positive diff value would mean that the students who took driver ed had a larger mean than those who did not. What if the diff value was 0? That just means that the means are going to be congruent. So when I look at the dot plot that we've created here, you'll notice that this dot plot is different than any of the other ones we've created. This one is centered around 0. Centered around 0 means that my means are congruent. So a diff value of 0 means that I'm going to have those points right there. So this dot plot is actually showing us our diff values, the difference between the means. When I look at this dot plot, I see that to the right I've got the positive diff values, showing that the students who took driver ed had a larger mean. And on the left side I've got the negative diff values, showing that the students who took driver ed had smaller means. So this brings us to our definition of statistically significant. We know that our diff values vary. The diff values vary and are normally due to chance. If an observed difference value is extreme, if it's far away from 0, then that's going to be considered statistically significant and not possibly the result of chance. So if there is a value that is statistically significant, most often it is because it is caused by the treatment that we are talking about in the question. So for example, the treatment of taking driver ed. As our rule of thumb, we are going to use if a value will happen less than 5% of the time, it is considered statistically significant. So I want to just take a look at the diff value that we got in the above example number 2. We had a diff value of negative 16.5. So when I look at negative 16.5 on my dot plot, it's going to be right about here. So a diff value of negative 16.5 is far away from 0. Negative 16.5, if I then go ahead and look at the ones that are beyond it, there are 3 of them that are beyond it. So negative 16.5 and anything more than that would occur in this case 3 out of 100 times. 3 out of 100 times gives me the decimal 0.03, and that of course is less than my 5%. It's less than 0.05. So I would say that a diff value of negative 16.5 is considered statistically significant. What that tells me is that the treatment, taking driver ed, caused that diff value to be that large. We're going to take a look at the last 3 questions together in class tomorrow. Thanks very much for working with me on diff values and finding the mean scores. Have a great night, and we'll see you tomorrow.